Common logarithms. Consider the equation 10 to the x equals 100. We know that the value of x is 2, since 10 squared is 100. However, not every equation that involves an exponent is this simple. Until now, we've had to rely on graphs, tables, and guessing and checking to solve equations like 10 to the x equals 50. To solve for x when x is the exponent, we can use logarithms. The rule that relates exponents and common logarithms is if 10 to the x equals a, then log base 10 of a equals x. Common logarithms are logarithms with a base equal to 10. The base of an exponent is the large number that has the exponent. For example, in the expression 10 to the x power, 10 is the base. When written as a logarithm, the base is the subscript written to the right of the word log. Having a base equal to 10 is so frequently used that you do not have to write the 10 when you're writing out a common logarithm equation. For example, log base 10 of a equals x is the same as writing log of a equals x. So you don't have to write the 10 here. Now you can take a logarithm of a different base, so if you were to do that, like if your base was 2 or any other number, then you would put the subscript here, but if you do not see a subscript, then you can assume that it is 10. Since finding a logarithm is the same thing as finding an exponent, you can only take a logarithm of a positive number. The reason is that since exponents represent repeated multiplication, there's no way that you can multiply a number like 10 to itself any number of times and get a negative number. Alright, let's look at some examples. For our first example, we have 10 to the x equals 100,000. So we have to think, how many times can we multiply 10 to itself to get 100,000? Well, the answer is 5. 10 times itself 5 times would get you 100,000. So we know that x equals 5. If we were to use logarithms to find this, we would say the log base 10, I don't have to write the base, of 100,000. We put that in our calculator, and it would give us the 5. Alright, let's look at number 2. So this is the same process here, except now we'll have to rely on the calculator. So I'm going to do log base 10 of 50 to get my x. So in the calculator, you do log of 50. And we can kind of go ahead and estimate to make sure that we know that the answer will be reasonable. I know that 10 to the 0 power equals 1, 10 to the first power equals 10, 10 to the second power will equal 100. So 50 is going to be somewhere between 10 and 100, which means my exponent is going to be somewhere between 1 and 2. So using the calculator, I put in log of 50, and I get 1.69897. So if I took 10 to the 1.69897 power, then I would get approximately 50. Now moving on to number 3, there is one more step that we have to do here. So we have to get, before we take the logarithm, we have to get 10 to its exponent by itself. So for number 3, the first thing I'm going to have to do is divide both sides by 5. So that gives me 10 to the x power equals 13. Now I can take the log base 10 of 13 and get x. And it's reasonable to think that my answer will be just slightly above 1. So I'm going to, in my calculator, put log of 13, and I get 1.11394. Alright, let's move on to number 4. Here there's more to do before I can take the log. I have to get 10 to the x by itself, so I'll start moving everything else to the other side of the equation. So I'll start by adding 3 to both sides. So that gives me 2 times 10 to the x equals 30. Then I'll divide both sides by 2. And I have 10 to the x equals 15. Now that I have 10 to its exponent by itself, I can do log base 10 of 15 equals x. So I turn to my calculator and plug in log of 15, and I get that x equals 1.17609. Alright, number 5. Again, I have to get 10 to its exponent by itself, so I'm going to add 8. So 5 times 10 to the 2x equals 23. Then I'll divide both sides by 5 and get 10 to the 2x equals 4.6. Right, now I'm ready to take the log of 4.6, and that equals the exponent, and my exponent is 2x. Alright, so if I find the log of 4.6, log base 10 of 4.6, I get 0.66, I'll round it here, 3 equals 2x. Then I'll divide both sides by 2 to get x by itself. And I'm keeping the decimals in the calculator, I just rounded it to write it. So I'm dividing by 2, and I get x equals 0.331. Alright, so x equals 0.331. Alright, we have one more example. Okay, for our last example, I'm going to, again, want to get 10 to its exponent by itself. So this equation looks really intimidated, but we'll just take it the same, like one step at a time, using the same process that we've been. So the first thing is to get 10 to its exponents by itself. So I subtract 5 on both sides, which gives me 2 to the 10, 2 times 10 to the 3x plus 2 equals 30. Then divide both sides by 2. So I have 10 to the 3x plus 2 equals 15. Alright, now I have 10 to its exponent by itself. So that means I can take the log base 10 of 15 and set that equal to the exponent, which is 3x plus 2. So I have to find the log of 15. And I get 1.17609 equals 3x plus 2. And now I just have this one equation to solve. So I subtract 2 on both sides, which gives me negative 0.8239 equals 3x. Then I'll divide by 3. And I get x equals negative 0.2746. Alright, so now's the time for you to pause the video and complete the independent practice. Once you have completed the independent practice, press play to check your answers. And here are your answers to the independent practice.